All right, let's take a look at a concrete, real life example of one of these questions in chapter 22 of discrete probability distributions. So here we go. Tickets in a game of chance can be purchased for $2. Each ticket has a 30% chance of winning $2, a 10% chance of winning $20, and otherwise just loses. How much might you expect to win or lose if you play the game 100 times? All right. Thinking about the skills that we've been learning and practicing in this particular chapter, so, standard deviation, variance, expected value, what out of those three that I've just mentioned do you think relates to this question? Well, looking at what the ultimate question is, how much might you expect to win or lose, the key word being expect, well, if you're thinking expected value, is spot on. So let's go ahead and write the formula for expected value. So let's do it. Expected value is basically equal to each of your scores within your sample space multiplied by their relative probabilities. So each score and their probability multiplied together, add all the scores up. So we need to, therefore, create a probability distribution in the form of a table. So let's do that now. Delete the background. Get another row here. All right, each of the scores at the top and their relative probabilities down below. All right, so the first one, we're going to have to introduce a new little concept here, and it's this. Our values in this particular question are related to our, let's point to it here, they relate to our discrete random variable. And in pink up the top, our discrete random variable in this particular case is winnings. How much are we winning each time that we play this game of chance? Whatever it is. It could be rolling a dice, flipping a coin, whatever it is. Our random variable is winnings. So let's consider our winnings here. So we have a 30% chance of winning $2. Right? So our first value is 2. So that 2 is going to go here. Our next is winning $20. That'll go here. And then otherwise losing, the value there is obviously $0. That'll go there. But we need to take into account a new bit of information now. And that is every time you play this game, you have to purchase, you have to invest your own money. How much? Well, the tickets can be purchased for $2. So out of each of these values that we could win or lose, we need to subtract $2 from each of them, because every time you play, you lose $2, because that's how much the game costs. So when we go ahead and write 2 here, it's actually going to be 2 take away 2, which will be 0. All right, so what's the chance or the likelihood? Let's just get a line here. Okay. The chance of winning $2 is 30%. So I'm going to write it like this here. 0.3. Okay, the next one. There is a 10% chance of winning $20. That means there is a 0.1 chance of winning $18, because remember, you invested $2 each time to do this. And the last one is you're winning nothing, so you're actually losing your $2 in the first place, and that is just the remainder of what's left. Okay, so we've got a 30% chance plus a 10% chance, that's 40% in total. The remaining must be 60% chance. So from here, we just apply our formula. So basically multiply each of our values by their relative probabilities, and then we add each of these together. And that'll get us our expected value, which is kind of like the mean, the average expected, in this case, expected amount of winning or win or loss per game. So let's do that. All right. So expected value will be 0 times 0.3 plus 18 times 0.1 plus negative 2 times 0.6, which will be, all right, so that'll be 0 plus, this will be 1.8 plus 2 lots, or negative 2 lots of 0.6 will be 1.2, but this time we're going to be subtracting 1.2 because it's negative. So subtract 1.2. All right, so 1.8 take 1.2 will be 0.6. And so that is the expected value for how much you would win per game. So it's positive. So this is a pretty good game. You're expected to win $0.6 or 60 cents per game. Fantastic. But the question is asking us, how much might you expect to win or lose? So far we've answered that. That's fine. It's $0.6 per game. But if you play the game 100 times. So what do we need to do here? For 100 games, you would expect to win, well, 0.6 times 100 games is $60. Now, just for your information, the textbook has it written as $80. That is 100% an error. So that's that. So let's quickly just look, and so we've answered our question. The answer's right here. We'd expect to win $60 over 100 games. So if we have a look now at our discrete random variable, which is winnings, because we have invested $2 each time we played the game, because that's the cost, in our case, our discrete random variable is our winnings, right? It's our winnings minus our investment. So the investment was always the $2. All right, thanks for watching.